Okay, the first part, to which sets of numbers does each number belong? So in the real number system, you have the most specific type of numbers are called natural numbers or counting numbers, and those are 1, 2, 3, etc. They're positive without decimals. The next set of numbers are whole numbers, and whole numbers start with 0 and then go up 1, 2, 3, etc. So whole numbers are just like natural numbers except for you're adding 0. The next set of numbers are integers, and integers are positive and negative whole numbers. So -3, -2, -1, 0, 1, 2, etc. The next numbers are rational numbers, and rational numbers are numbers that can be written as fractions. So they can be positive and negative decimals that stop or repeat. And then if the numbers aren't rational, they're irrational. So irrationals are decimals that go on forever without a pattern. So this first part, to which sets of numbers, so you have to name all the sets of numbers. So this one has a pi in it. Pi is a number that goes on forever without a pattern, so this is irrational and real. 79 is a natural number, which makes it automatically a whole number, an integer, a rational number, and a real number. Square root of 121 is 11, so this one's going to be the same. Natural, whole, integer, rational, real. Square root of 200 is a decimal that goes on forever, so it's irrational, and it's also real. And then this is a fraction, so it's rational and real. Compare numbers using greater than or less than. So on a number line, if you have 0, -2/3 is not quite -1, and -3/2 is over here. So the numbers that are going this way are greater, so -2/3 is greater. And then square root of 6 and 2.3 repeating. If I do the square root of 6, I get 2.4 approximately. So square root of 6 is greater. These both have the same 10 spots, but the 100 spot has 5 over here, so this one's greater. And then the absolute value of -7 is 7. So if you're comparing -7 and 7, 7 is greater. So find the opposite and reciprocal. So opposite means you just take the opposite sign. So I'm going to do all the opposites first. So opposite is positive 3.4. Opposite of 4 plus pi is -4 minus pi. I made both of them opposite. And this is -1 7/8. And this is -√12. Now the reciprocal means you have to flip the numerator and denominator around. So I'm not going to do, it's weird to do, you never want to mix fractions and decimals. So what I'm going to do is I'm going to write -3 4/10, which is the same thing as -3 2/5 if I reduce it. So to write this as an improper fraction, I do -3 times 5 plus 2. So it's -17/5. Actually, you just do 3 2/5 and then add a negative on. So then the reciprocal of this number is flip this around, and it's -5/17. That's the reciprocal. The reciprocal of 4 plus pi is 1 over 4 plus pi. And that's my answer here. The reciprocal of 1 7/8 is, I'm going to write it as an improper fraction, so that's 15/8. And then I'm going to flip it around. So the reciprocal is 8/15. And then the reciprocal for this one is 1 over √12. So if you remember, you always want to rationalize it. So I multiply the top and the bottom by √12. So the top part's going to be √12, and the bottom part's going to be 12, because √12 times √12 is 12. But you need to break down the square root of 12. So square root of 12 breaks down into 2, 6, 2, 3. So this breaks down to 2 root 3 over 12. And we can reduce the numbers that are outside the fraction, or outside the square root. So it's root 3 over 6. And then the next part, evaluate. So when you evaluate, this horrible printing job, but these two had absolute values in it. So when you evaluate, you need to do, I would simplify it first before I plugged this number in. So I can't really do anything to simplify this, so I'm going to plug in 2. So the negative is on the outside of here, so it's opposite of 2 squared plus absolute value 2 minus 10. So 2 squared is 4, so this is negative 4, plus 2 minus 10 is negative 8, but absolute value is going to make it negative 4 plus 8, so the answer is 4. So here, this negative is outside the x squared. You're not doing negative 2 times negative 2, you're doing 2 squared and taking the opposite of it. And then here, I'm going to distribute first. So it's going to be 3t squared plus 6t. Then I'm going to distribute this negative through, minus 3t squared minus 5t. So it's better that I simplified first, because then I'm just left with a t. So if t is equal to 19, then this answer is 19. So much easier to simplify first. And then this one, I'm going to simplify first. It's hard to read again, but this is 3a minus 2b plus 3a plus 3b. Well, I guess this one doesn't even read that you have to evaluate, you just have to simplify it. So I did the distributive property, and now I'm going to combine my 3a's. So 3a and 3a is 6a, cross, cross. Negative 2b and 3b is b. So here's my answer. And down here, solve for x, state any restrictions. Stating restrictions is more of what you're going to do in Algebra 2, but when you state restrictions, it means that you do not want a 0 in the denominator ever. So when there comes up one where I'll explain it. You don't want a 0 in the denominator. So number 32, I add 5, so I get 2x equals 22. So then I divide by 2, so x equals 11. There's not any restrictions right here because I never have a variable in the denominator, so I'm never dividing by 0. And then for 33, just get used to the technique of, I'm going to clear fractions on this. I could subtract 8 and then multiply by the reciprocal, but I want to review how to clear fractions. So if I have this 2 in the denominator, that's the only denominator, I'm going to multiply everything through by 2 because it will clear fractions. So this is going to turn into 16 minus x equals 6. 16, take away x has to be 10. And I don't have any restrictions because I never have a 0 or a variable in the denominator. And then now 34, I have x's on each side, so I'm going to subtract 4x. So I'll have, these cancel out, so I have negative x equals negative 5. So if I divide by negative 1, x equals 5. And again, I don't have any variables in my denominator. 35. Just like I cleared fractions, you can also clear decimals. All of these these numbers have the 10 spot. So if I have 10 spot, the tenths, I'm going to multiply by 10. If I have a decimal that has a 100th spot, so 2 decimals, I'm going to multiply by 100. So this one I'm going to multiply everything through by 10. Alright, right here. So 1/10 of 10 is just x, plus 1.4 times 10 is 14, equals 12x minus 30. So I'm going to get my x's on one side, subtract 14, get my numbers on the other. So I'll have, this cancels out, negative 13x, negative 11x equals negative 44, so x is 4. I don't have any variables in the denominator ever, so no restrictions so far. Alright, and then this one right here, 36, I would get this 3 out of the denominator, so I'm going to multiply both sides by 3. Sorry, this is horrible quality. And then I'm going to get 7 minus x equals 15. And I subtract 7, so negative x equals 8. So x has to equal negative 8. I still don't have any variables in the denominator. So then over here, 37, I would, if I'm solving for x, I'm going to cross multiply. I see a proportion. I see two fractions that are equal. So I'm going to cross multiply. So a times x plus a equals b. So if I'm going to solve for x, my own thing is I'm not going to do the distributive property. You could, but I'm going to divide both sides by a first. So I have x plus a equals b over a. And then I'm going to subtract a. So x equals b over a minus a. So this one's going to have restrictions. So this would mean that when you're solving for x, there's no way you could never have b be equal to 0 or a be equal to 0, because then you'd be dividing by a 0, and you can't do that. So my restrictions are going to be, I cannot have a be equal to 0, and can I not have b be equal to 0? That's in my original problem. Then I look through, do I ever have anything else in the denominator besides an a dividing by a or dividing by b? I don't. So that's those are my restrictions. So we have to look at not only in your original problem, but is there any point are you dividing by 0? So that's the first part. So hopefully you remembered some of this from Algebra 1.